Okay, we started off the chapter talking about ratios and proportions so that we could talk about similar polygons. Just like last section, this shouldn't be anything new. This should all be things that you've learned before. But we'll use this video as a little bit of a refresher. So similar polygons, we have talked about another type. We talked about congruent polygons already this year. So polygons that are similar have the same shape, but a different size. So we knew they're congruent if they have all angles are congruent and if all sides are congruent as well. So we saw that with triangles and with quadrilaterals. The ratio of corresponding sides is called the scale factor, which we abbreviate as K. And that also was present when we talked about dilation. So when we took a shape and we made it bigger, we applied a scale factor. We multiplied the size of this by K to get the size of that. So K is like the multiplier that takes us from one shape to the other. And if this is a new shape and an old shape, we find K by dividing the new size over the old size. So yeah, that's that. Notice that we end up with something here that looks like a ratio when we do that. And then if polygons are similar, their sides are proportional. So proportional means we're going to have the same ratio for all sides of the polygon. In this case here a triangle, but could be any number of sides. All right, what is the scale factor from ABC to DEF? So if we're changing this shape into this one, we want to see what are we multiplying by to get from here to here. So we know that since they're similar, all three sides are going to be the same ratio. So we really just need one of them. And again, we're going to take the new shape, this one, and divide by the old shape. So we're going to do, like, for example, DE over its corresponding side, AB. And that would be 12 over 8. So our scale factor would be 3 to 2, or 3 halves, or 1.5. 1.5, 3 halves, whatever. As long as it's a terminating decimal, that's fine. Now if we go the other way, what is the scale factor from DEF to ABC? So this says here, order matters, because now we're going the other way. We're saying, what would we multiply this by to turn it into this? It's getting smaller, so we know that K has to be less than 1. So this time, we're going to say we're creating AB as the new side, and the old side it came from was DE. So that would be 8 over 12. So we end up with a scale factor of 2/3. So I'll write that as a fraction. Could have written this as a fraction too. Okay, now the last thing says, what is the ratio of the perimeter of DEF to the perimeter of ABC? So we're saying perimeter of triangle DEF to the perimeter of triangle ABC. So this ratio puts the perimeter of DEF on top and the perimeter of ABC on bottom. This dividing line means 2. We can also think of it with the colon. We could say perimeter of DEF. Again, this means 2, the perimeter of triangle ABC. This way is more palatable to me because it's like a fraction, but either of these will mean the same. So DEF has a perimeter of 12, 39, 54, and ABC has a perimeter of 8, 26, 36. Those are both divisible by 9, so I could do this as 6 over 4. And then that further simplifies to 3 halves, which is really meaning a ratio of 3 to 2. So I could also write it this way. So my ratio is 3 to 2, and I think the reason they had us investigate this is, if we look at the scale factor of DEF to ABC, we went from big to small, that gave us a scale factor of 2/3. but our ratio of perimeters is the reciprocal of that. It was 3 to 2. So whether you're doing a scale factor or a ratio of the measurements determines what thing goes on top. So just keep this thing you already have learned before in mind, where if we're doing scale factor, we put new over old. If we're doing a ratio of that to that, then yeah. So it's confusing to me because both of them have this word to, but they mean different things. So the scale factor means we're transforming this shape into that one, whereas this to means this ratio, basically ratio symbol. So it's reversing the orientation of those. Okay, similarity statements. So just like we had congruent statements that told us what corresponding parts match up, we have a similarity statement. And instead of the congruent symbol, which was equals with this little wavy guy on top, our symbol for similar is just that little wavy guy by itself with no equals underneath it. So we'll write a similarity statement that looks very much like a congruent statement. So for this one, we need to make sure we name the vertices in the corresponding order. So I'm going to go angle 1, 2, 3. That gives me triangle ABC. I'm going to say is similar to, same order, 1, 2, 3 goes DEF. Triangle DEF. And that matches up all our corresponding parts. A goes with D, B goes with E, and so on. So identifying matching parts, we have this triangle JKL is similar to triangle PMN. That means these pictures are irrelevant. We don't need them at all because we know that angle J goes with angle P. Angle J is congruent to angle P. So even though these are similar triangles, they still have 3 congruent angles. So angle K is congruent to angle M, and angle L is congruent to angle N. So those are our 3 matching angles. Our matching sides are not congruent though, because we have a big shape and a small shape. But they are similar, so that means they're proportional. So we can say that JK is the same length as PM. Sorry, no. The ratio of JK to PM is the same as the ratio of KL to MN. Remember, these are lengths, so we're not putting segment notation over them because we're not talking about the segments themselves, we're talking about how long the segments are. And then our final side goes LJ to NP. So this is our extended proportion that tells us these ratios are all equal. All right, second one is the same thing, because again, the picture doesn't matter. So the fact that there's a different looking picture has no relevance to naming the corresponding angles and the corresponding sides. We just need to use this statement here, which I just marked through. So feel free to do that one on your own, and then I'll move on to the next thing. So we got a third practice, but for a quadrilateral. Makes no difference. We're still going to just follow the corresponding angles and the corresponding sides to set this up. The main difference is our extended proportion is going to have 4 ratios instead of 3 because there's 4 sides. Now we're going to let's look at these for actually solving something. All right, so number 4, it says they're similar with a scale factor of 2 to 3. So that means that wow, so they're just defining scale factor backwards here of how we normally do. Interesting. So when they say a scale factor of 2 to 3, they're not actually saying what the K value is. So pay attention, since this is a ratio, it means that, and we can also see the sizes, right? So this is 2/3 as big as that one, meaning our K value is 1.5 or 3/2. So what's important here is we know that shape 1 is 2 and shape 2 is 3, and then our corresponding side is 42 over x. If we solve this, we end up with 2x equals 126, so x equals 63. I ended up with a bigger number, right? We started with 42, we ended up with 63. So it's important that I double check that yes, we were getting bigger, at least if this is drawn to scale or somewhat to scale. I find this very confusing that they're using 2 to 3 as a scale factor rather than the k value, which is the multiplier. So I wouldn't call this a scale factor. I would call this a ratio of the sizes of the two shapes. But whatever, we can deal with it. Okay, so if the figure below are similar with a scale factor of 6 to 5, meaning k equals 5/6, so we're getting smaller, then we want to find the value of x. So if we're multiplying, I could think of it as 5/6 of x equals 28, or I could set up the proportion as x over 28 equals this ratio of 6 to 5. Either way, I get the same thing. Like what I've written over here and here are equivalent statements. If I just multiply some things, I end up with the same thing either way. So I get x equals 28 times 6 over 5. So that's 120 plus 48, so 168 over 5. And that doesn't simplify, so that always makes me worry I've done something wrong. 5/6 of x is 28. That seems right. Okay, so I guess we just end up with this fraction that doesn't simplify. We could change it to a decimal, I guess, and do 33.6, but whatever. Either way, what's important is it's bigger, and this was supposed to be the bigger shape with the 6 to 5 ratio. All right, I'll let you do the other two, like the same kind of thing. You're just matching up which side. The one difference I see here is they're labeling multiple sides, so just make sure you're matching up the right one. So we're given PS. Oh, they're not giving us the ratio, so let's go ahead and check. So PS, first and last letter, goes with WZ. So 40 to 75, what are we multiplying by? We're multiplying by a little less than 2. 40 over 75 equals, and then we're going to relate the other two, 32 over x. So important thing there was both top numbers were from the same shape, both bottom numbers were from the same shape. So we end up with what? X equals 32 times 75 divided by 40. So rather than multiplying that out and getting huge numbers, I'm going to try to simplify where I can. So 75 and 40 are divisible by 5, so that would be 8, and that would be 15. 32 is divisible by 8, so that makes 4. So this simplifies to x equals 60. So that's, to me, a lot easier than dealing with really big numbers, is to just treat it as like simplifying a fraction and canceling and simplifying things to make it as easy as you can before doing any like long division type thing. Okay, so theorem, similar polygons, we already kind of understand that if we have a ratio of each side of similar shapes, that's the same as the ratio of the perimeter of those shapes. So it makes sense that if we added up all the numerators and all the denominators, they'd still be equal. So that's our theorem there about perimeters. And let's see if we want to do it. So that's pretty much the notes for today, but I'll do a couple more practice problems in case you are still feeling unconfident. So if you are cool with this, then feel free to move on and work on this practice on your own. If you need a little bit of a confidence boost for me to do some with you, I'll go through a few more problems. All right, so JKL goes with NML. So we're going to match JK with NM by our similarity statement. So I kind of like putting the smaller shape on top. So I'm going to do 16 over 40 equals 14 over, this was LM, it corresponds to LK, so that would be over X. And then LN is Y over, it must be this one, right? So LN is first and third, LJ, 45, is our remaining side. Okay, so remember that when we have this extended ratio or extended proportion here, we only need to consider two at a time. So I'm going to kind of block off the y and just look at these two and solve for x. So if I rearrange it to solve for x, I get x equals 14 times 40 over 16. So I'm just using multiplication and division to multiply the x over here, multiply the 40 over here, and divide the 16 over here. So I just move my terms around, and 16 and 40 are divisible by 4, so that's a 4 and a 10. And then this would be 7 and 2, and that would be 5. So x equals 35. Then, now that I know that, I can either use 14 over 35 equals that, or I can go back to 16 over 40 equals that. It doesn't matter. I'm going to go back to my original number just arbitrarily and say y equals, since y was already on top, I have 16 over 40, and then I'm going to multiply this 45 so that it goes to the top over here. 40 and 45 are divisible by 5, so that's 8, 9. 16 over 8 is 2, so y equals 18. So that's how we would do that one. Let's go down to one with let's go to one that has operations like this. So this is the last one that I'll do in the video. We have MNP is congruent to QRP. So let's look. We've got, kind of want this thing on top. So I'm going to put 3x minus 9 over, that's PR, it corresponds to PN. So that goes over x plus 8. And that equals, from the same shape, right? I started with this shape, so this is like shape 1, shape 2. I'm going to take this 28, which was PQ. That corresponds to PM, which is 24. Now I have options for how to proceed from here. The first thing I notice is that these can simplify by dividing by 4. So I'm going to do that and say that equals 7 over 6. Then I'm going to basically cross multiply. I'm going to multiply this by 6 and 7 by this to get everything where it belongs. So we're going to have 6 times 3x minus 9 equals 7 times x plus 8. And then we distribute, we get 18x minus 54 equals 7x plus 56. So bringing these over, we get 11x, and bringing these over, we get 110. So x equals 10. All right, so that's how we could work some of these problems. It's all about reading those similarity statements, matching up the correct sides, and then setting up our proportions. So hopefully that helps jog your memory on this one, and we'll continue on in the next video.